Hi, everybody. Welcome back to Learning Solidity by reading the Effin' Ducks. This is Eric from the Right Click Save project, and today is going to be a little different in that we are not going to read or write any Solidity code, but instead, what we need to do is give ourselves a conceptual model of the blockchain as it pertains to writing smart contracts. So there's two concepts we need to know about, and those are transactions and blocks. Now, there's many other things, like it says here, hashing, mining, peer-to-peer networks, cryptography. Those are all good things to know as blockchain engineers. Not what we're going over today. Today, we're talking about transactions and blocks. So I have a little diagram for you here. Let's see, there we go. And so when you think of the blockchain, we've heard it described as a distributed ledger. So, a ledger is basically a series of chronologically ordered transactions. And in our case, we have a little example here. So, first entry in our ledger is transaction number 1. Guy named Joe deposits 100 ETH. Transaction 2, completely unrelated. A woman named Sally votes for someone named Tom in a local election, and that's done via smart contract. Transaction number 3, Joe withdraws that 100 ETH. And transaction 4, another unrelated person, maybe Esther, she wrote a counter smart contract because she's teaching herself Solidity and she wants to update a state variable. And transaction 5, Joe withdraws 50 ETH. Now, wait a minute. Joe deposits 100. He withdraws that 100, doesn't have any ETH left. How's he supposed to withdraw that other 50 ETH? So this is what's called the double spend problem. And this is something that the blockchain has solved for us. And we need to basically just write our smart contracts with the understanding and the confidence that this is not going to be an issue for us. And I'll explain how in a second. So basically, one thing we need to understand about transactions is that they can fail. So for example, if transactions 1, 2, 3, and 4 are added to the blockchain, as the blockchain is processing transaction 5 here, it's gonna see, wait a minute, Joe no longer has any ETH in his account, and therefore we're not gonna add this transaction. This transaction will fail, it will revert, and no state will be updated on the blockchain. Furthermore, we also need to understand about transactions that they are signed, cryptographically signed, meaning that only Joe or the account associated with Joe's money can actually write these transactions to the blockchain. Sally, not knowing Joe, cannot withdraw money from Joe's account because she does not have the access via her Lord, I'm stuttering, via her account. So that's basically it. What is a transaction? It is nothing more or less than one record entry into our ledger, one entry into our database. So conceptually, we can think of these as transactions that all happen in order. They are cryptographically signed, and they can fail if need be. They might not be added to the blockchain. And what is a block? Well, quite simply, a block is a group of transactions. Transactions are not added one by one to the blockchain. They are added in clusters, that cluster being a block. And these blocks will always maintain that order. So for example, our transactions 1 and 2, where Joe deposits 100 ETH and Sally votes for Tom, those would be bundled up into block 1, added to the blockchain. And then transactions 3 and 4, where Joe withdraws that 100 ETH and Esther upstates her state variable, those will be bundled up into block number 2. That will be added to the blockchain. And block number 2 will point to block number 1. And if we add block number 3 here, that will point to block number 2. So any given block that's added to the blockchain can essentially read any block that has come before it, and from there gather the information needed. So for example, if we try to add transaction 5 here inside a block, and that block is being processed, that block will see, can read, hey, Joe deposited that 100 ETH in block number 1, withdrew it in block number 2. Therefore, there's none of that ETH left for us to process this. So block number 3 will revert and not be added. So that's pretty much it. And what do we have here? These blocks, they point to each other, they form a chain. That's what a blockchain is. So conceptually speaking, a blockchain is a series of blocks, sequential series of blocks that point to it, that can read from previous blocks. And each block is composed of a group of transactions of our ledger. And that is it. So let's go to an example here. Now, the real life example. If you're not using Etherscan, you absolutely should. And we can expect a whole blockchain here. So let's do it. So we can view our blocks. So 8 seconds ago, a block number, let's see, 16,812,755 was added to the blockchain. It is composed of 140 transactions that we can look at here. And those transactions involve transferring ETH from someone to another, approving. This isn't someone interacting with a smart contract, somebody minting probably an NFT here. And we can even go all the way back to the beginning and inspect. Okay, let's see if we can get this to load here. There we go. This is block number 0. This is the first block. Look at that, the Genesis block of the Ethereum blockchain. So we can expect all the way back to the beginning. And that is it. I hope this was helpful. And we'll see you in the next video. My name is Eric, and I work for CryptoPunks.